Welcome back. Today we are continuing the circle geometry that we are treating. Going to part 3. Now, circle geometry. Now, we proved a theorem the other time that is angle at the center is 2 times the angle on the circumference, or the angle the arc of a circle subtend at the center of the circle is 2 times the angle is subtend at any part of the remaining circumference. That's it. Then today let's consider another theorem like angle at the same segment. Angles at the same segment. Now, I told you the other time about major segments and minor segments. Like if this line is a chord, then you have this part to the what segment, minor segment, and this part of major segment. This one says that angle at this we are talking about angle at the same segment. So you can look at this. It's going to come from the previous one that we proved. So just follow. Now look at this. Let's call this place A, B, C. Okay. Let have this place as P, Q, R, X. Let have this place as P, Q, R, X. Now, what do we want to prove? We want to prove that angle on the same segment are equal. Let's say that this is center O. So what you will have is that what we are going to have here is that, let's say we have to given, what you are given here is a circle A B Q R S B with center O. Here you have the center of the circle. Again, right? Is there any construction there? Don't need anything. So what you have here is what do you want to prove? So you should prove that angles at the same segments are equal. That's it. You have to prove that angle at the same segment are equal. So how are you going to prove it? As I told you the other time, it's going to boil out from the one we proved. So I can tell you now that the previous one that we talked about, that angle at the center, that is the angle, the arc of a circle subtend. This is the arc of a circle. The angle, this angle that is subtend is equal to is 2 times any angle that is subtend on any part of the remaining circumference. This is the remaining part of the circumference. Any angle that is subtend there, even if I draw another one here, if I draw another one, they are all on the remaining part of the circumference, which is a major segment. So what you simply prove here is this, that angle AOB is 2 times of angle, look, angle AOB is 2 times of angle ABB. is 2 times of angle APB. So you put the proof there. Angle at the center is twice the angle on the circumference. So you have that. Then again, if you have this likewise, angle AOB, this angle on the circumference, this angle at the center, this angle 2 times this place. Again, this angle again is 2 times angle of what? AQB. So this is 2 times of angle AQB. So you simply say the same reason. Again, angle AOB is equal to angle ARB. So that is 2 times of angle ARB. Same reason. Even if you have them 10 like that, it's going to be the same reason. So lastly, angle AOB is equal to 2 times of angle ASB. So you have them as the same reason. Now look, all this one, they have the same reason. So what do you see? All these two angles you see, they are all equal to angle AOB. They are all angle AOB. Therefore, angle AOB is equal to 2 times of the following. Is equal to 2 times of all. So you can just say that all these angles are the same. So therefore, 2APB is equal to 2 times AQB is equal to 2 times ARB is equal to 2 times ASB. So what you have here is this. These two cancel out. Therefore, angle APB is equal to angle AQB is equal to angle ARB is equal to angle ASB. So you prove it. That's it. QED. So it has been proved that the angle at the same segment, they are equal. So this is what you call angle at the same segment. They are all equal. If this place is A, this one will be A, this one will be A, this one will be A. They are all equal. Anywhere you see, they are equal. So that is that. That's the proof of angle at the same segment. Now, so if they ask you to prove it, so you know that it's as simple as that. Now, let's go to another theory. Before we do example, let's talk about other theory. Then, what you have here is, let's look at angle at the semicircle. Angle at the a semicircle is half of a circle. So, just look at this. Let's say you have this center. Let's call this place A, B, C. We label it like that. What you have to prove is that prove that angle at a semicircle is equal to 90 degrees. We prove that angle at the semicircle is equal to 90 degrees. So this is what we want to prove. Then what are you given? What you are given here is a circle ABC with center O. Then his own proof is very simple. So simple. So what do you want to do here is that if you remember, this angle you are seeing is angle on a straight line. And you remember that sum of angle on a straight line is 180 degrees. At the same time, this place, let's just look at it. This angle here is what we refer to as angle at the center. That is twice the angle on the circumference. So you can simply write that angle AOC is equal to 2 times of angle ABB. So you put the proof here, angle at the center is twice the angle on the circumference. So you have it like this. The angle at the center is twice the angle on the circumference. So, and then angle AOC is equal to 180 degrees. That's sum of angles on a straight line. That's sum of angle on a straight line. This angle here is 180 degrees. That's sum of angle on a straight line. Therefore, since AOC is 180, which is angle at the center, so you substitute this 180 for this place, then you have 180 degrees equal to 2 ABC, 2ABC. That is 2 times ABC. So you can divide both sides by 2. Then you will have ABC equal to, this is 90 degrees, equal to 90 degrees. So you have proved it. So that's it. It's that simple. So as you are going, once you put your mind into this theorem, I said you ask you to prove. Just note that when you see a diameter like this with center hole and an angle here obtained on the circumference of the circle, simply know that such an angle is 90 degrees. That is that. All right. Before we start doing the example, let's look at another theorem. Let's look at another theorem. Now, the other theorem we are going to now is angle, the sum of two opposite angles of a cyclic chord. They are supplement. Supplementary angle are angle that the two angles you have together that give you 180. We have complementary angle also, which two angles you have together that give you 90 degrees. So here you have a cyclic chord. Cyclic quadrilateral. Now, what you have is this. What you have is this. Then a cyclic chord. So you can have this one as center. So let's call this place X, and let's call this place Y. So we can have this place as A, B, C, D. Now, this is what we have. Now, given. What they give you here is what? Is circle a cyclic chord quadrilateral A, ABCD with center O. With center O. This is cyclic collaterals with center O. Then, though I've done that one, you can say that construction. What you construct is a line. You construct a line from angle A. You construct a line from angle A through the center of the circle, joining angle C. So that's it. This is the construction. You construct because you are just given a cyclic chord. Then you join this one together with center to this side. That's what they ask you to prove. Prove that angle. Prove that the sum of two opposite angle of a cyclic chord are supplement. They are supplementary. This is what we want to prove that the sum of two opposite angles of a cyclic chord are supplementary. That is, if you add this and this together, you will get 180 degrees. It's very simple also. So it's still following the first principle that we or the one that we prove. That's angle at the center is 2 times the angle on the circumference. So let's go. What you see here is that angle here is center O. Now, the angle you have here are two angles. You have this one, then you have this one. One is obtuse angle, the other is reflex angle, and they are both angle AOC. So if you want to prove it, it's still the same thing. If this is x, you know this angle on the circumference is 2 times of this place. Multiply x by 2, you get this. So that's what we are going. So here you have angle AOC is equal to 2 times of angle ABC. Then you put together that angle at the center is twice the angle on the circumference. That's it. That is AOC. This angle AOC is 2 times of this. So you have angle AOC equal to 2 times x. So AOC will be what? 2x. You have that one like that. Again, that's for this place, obtuse angle. Then, what about the reflex angle? Same way. Angle AOC is equal to 2 times of angle ADC. ADC. So, you simply put it there as same reason. They are the same reason with this. So, you have then angle AOC equal to 2y. That is 2 times y. It's still the same thing. Then, this angle here, there are two. So that angle AOC plus angle AOC, that is the reflex angle plus obtuse angle AOC, equal to 360 degrees. That's sum of angles at a point. That's sum of angle at a point. Sum of angle at a point is equal to 360. So what you have here is 2x plus 2y equal to 360 degrees. So to add them together, here is 2x, multiply this one by 2, you have 2y. So the sum of angle at the point is 360 degrees. So x, if you factor out 2, here is 2x. If you factor out 2, y equal to 360 degrees. So you divide this one by this. That's 180. So here you will have x plus y equal to 180 degrees. So you prove it. That is angle A BC plus angle A DC equal to 180 degrees. So you prove it. Very simple. Very simple. Just know the theorem. The first theorem gets most of the theorem, that all the other theorem is based on it. So let's do some example now. Let's say you have example 1. Let's have this. Then just the former one we have. Now, if this place is 50 degrees, let's say A, B, C, D, E, F, this center O. Then here is X, where X, we have X, Y, we have, let's say A, B, C, D. Then you have to find the value of A, B, C, and D. Now, look at this one. Find the value of this. Since this angle is 50 degrees, angle at the same segment. So you can say that if you want to find A, this is A. That's angle ECF. So you can say that is angle A. A equal to what? 50 degrees. So it's angle at the same segment. You have it, you just put the proof there like that. The same thing with B. 50 degrees. Same reason. So the same thing with C. 50 degrees. Same reason. Then remain D. If you look at D, D is angle at the center. So you can pick any of them. That angle AOC is 2 times of angle EDF. I use this one. That is this angle here, angle EDF, is 2 times of this. So you put it there like that. So you say that angle at the center is twice the angle on the circumference. So angle AOC equal to 2 times 50 degrees. So equal to 100. So you calculated it. It's as simple as that. It's as simple as that. Now, look at another one. Now you have to find the value of of A, B, C, D. Now look at something. Here you are asked to find the value of angle ABCD given this information. Now how? So you start from A. The first thing you are going to look at, just look at it, is your field. What are you seeing? It is what you are seeing that you are going to answer. So you look at it. What are you seeing? So if you look at this one, this is center of the circle. So something go like this, come like this, like this. So you can add this one as well. Like this one now. This one is like the theorem we proved the other time. A, angle at the semicircle. But this center of the circle. Then the center of the circle facing this place. So if this one is what? Angle at the semicircle. So here, you can see that angle A equal to 90 degrees. So you say it's angle at a semicircle. That is all. Angle at a semicircle. Look at something again. This angle C is same thing with this. The same angle at semicircle. In another way, you can look at it like this. This angle A is equal to this. You can call it angle on the same segment. See, this is the segment. Their angle at the same segment also. So, okay, angle A. Let's have this place as D. C. There's no C there. Now, let's say you have here is A. Okay, C is here. B up. Now you are getting A. Let's do it sequentially. Look at this one. B. It's like the last theorem that we proved. Look at it. Cyclic chord. That's it. This one is cyclic chord. Again, look at this one again. So you can prove it like that using cyclic chord theorem. It's not until you must use a particular theorem that it's several theorems can apply, can solve a particular question, as you have seen. A here is 90. So if you want to use cyclic chord theorem, you are right. If you want to use angle, what do you call it, at the semicircle, you are right. You are all welcome. So if you say that angle B now equal to what? 90 degree. So you can have it like that. That's angle, so we call it same reason. Same reason. If you want to use a cyclic chord, you simply say angle A plus angle B equal to 180 degree. That's sum of angle. That's sum of two opposite angles of a cyclic chord. They are supplement. They are 180. So one is 90. Then you substitute for the other. So you minus 90 from both sides. You will still get 90. That is it. So angle B is 90 degree. Again, look at C. Look at C. C, as I said the other time, is 90 degree. As I told you the other time, is T angle at the semicircle, or you can say it's angle at the same segment. So let me change it now and say that A equal to D to C, which is equal to what? 90 degree. Then I call it angle at the same segment. So two theorems can solve a particular question. You don't see me? So here, this equal to this. They are at the same segment. Or you can say, oh, this angle, so that is it. Again, D. Want to calculate D. If you want to find the value for D, look at it. Look at this angle. It's the same thing with this. This angle is the same thing with this. So you can say that D equal to 20 degree. So its angle at the same segment. Same segment. Let's label this place CE. So if you want to find E, if you want to find E from here, you can find it in any way. So it's not until one, maybe you must use one way. No. You can use several ways. So like this one now, if you want to find this value of A, you simply look at it again. So just look at this triangle. Are you seeing this triangle? So you can use some of angle in a triangle. So you can simply say that angle, this angle here. Let's label it A, B, C, D. Then you have center O. So you can say that in triangle A, DC, in triangle A, DC. So you can have angle A, DC plus angle D, AC plus angle A, CD equal to 180 degree. That's sum of angles in a triangle. So the short form, so you can write it for sum of angle in a triangle. So then angle D, this one is D. So what's the value of this one is D? D, as you know it there, is 20. That's D. Then angle A is A that you want to calculate. Then this angle C is A plus what? 35 degree equal to 180 degree. So what is D? D is 20. What is E? Okay, that's what you want to calculate. What is A? 90 degree plus 35 degree equal to 180 degree. So you add them together. That's 110, 145. So you have 145 degree plus E equal to 180 degree. So collect the light time. E equal to 180 degree minus 145 degree. So E equal to, that's 35 degree. So we are through with it. Now let's do one example more. Let's say you have this. So let's say we have this. Now, mm, now let me label it. Let's say A, B, C, D, E. Now, as to find the value of angle A, B, C, D, and E. So just look at it. Now, look at this one from here. What you are seeing is angle on a straight line. Angle on a straight line. So you can simply have A as A plus 68 degree equal to 180 degree. So this is sum of angle on a straight line. So it's just something like the sum of angle on a straight line. So collect the light time. A equal to 180 degree minus 68 degree. So A equal to what? That's 112 degree. So you have it like that. That's 112 degree. That's A. There is a theorem that will tell you. The theorem states that this angle you are seeing is an exterior angle of a cyclic chord, which is equal to one opposite interior angle. That's a theorem. If you have something like this, and this one produced like this, if this one is A, this way will be A. The theorem is an exterior angle of a cyclic chord is equal to one opposite exterior angle. So, is that exterior? They are equal. So, you can have it like that. You can prove it like that. Or in another way, if you don't want to go like that, you can go this way. You can say that A plus B equal to 180 degree. So you say that sum of two opposite angles of a cyclic chord are supplementary. So they are supplementary. So A is 112, 112 degree plus B equal to 180 degree. So B equal to what? 180 degree from up. So B equal to, so you minus it. So you get 68 degree. This is what I'm saying. This angle equal to this. And the proof is that an exterior angle of a cyclic chord is equal to one opposite interior angle. So that is it. Again, let's calculate D. Move it to D. D, you can see the angle, look at PSR, angle PSR equal to angle PXR, or let me do it like this. See, angle POR, angle POR, we're talking about reflex angle there, or there are two angles there, is equal to 2 times of angle PXR. Look, angle POR is 2 times of angle PSR. So you put it there again, that's angle at the center is twice the angle on the circumference. So that's it. So angle POR is equal to 2 times of angle what? That's PSR, which is what? Say 112. So you will have 224 degree. That's it. Then that's angle D. So if you want to calculate angle C, is angle at a point. So know that angle at a point. So you can say D plus, in short form, D plus C equal to 360 degree. So you say sum of angle at a point. So that's sum of angle at a point. So you have it like that. So you know C now, that's 224 degree plus C equal to 360 degree. So C equal to 360 degree minus 224 degree. C equal to, so you have 360 minus 224. That's 136. So angle C is 136. You calculated A, B, C. Then remain E. Gotten B, yes. Then remain E. Now look. You want to calculate angle E. Look at it. The angle on the same segment. This is it. They are on major segment. So simply say the angle B, or you can say the angle P, Q, R, O. I did not label it well. Also, you can say that angle E equal to angle B equal to angle E. They are angle on the same segment. So, okay, angle at the same segment. So, here you have E now, we give you what? B. The value of angle, that's 68 degree. That's it. It's so simple. So, in any way that you want to do it, you can always do it. So, if you need further explanation or any question that you want to ask as regard this part, you can forward it to the comment section. So we're explaining to you anyone that you'll be trying to solve that you cannot solve. So you can just forward it. We attend to it. Thanks for watching.